This is the start of Section 3 in Chapter 6, Water and Solutions. Water is very, very important to all life. One thing that it does is that it helps to maintain homeostasis. Homeostasis means balance. An example of this would be you sweating. If you could not sweat or release that heat from your body, your temperature would get out of balance and you technically would boil. Another example is when you cramp. Sometimes you do not have enough water in your body and your body begins to go out of whack or out of balance and it begins to cramp, and that's how you get cramps in your arms, your legs, or other places. Water also makes up 70% of a cell's mass. Not 70% of your body, 70% of each and every cell that you have in your body. That is why water is a very, very important molecule for all life. Water has a few properties. We've already talked about that it does go or use covalent bonds, meaning it shares electrons. Because of that sharing, it ends up having an unequal distribution of electrons, meaning it has a positive end and it has a negative end. As you can see by the diagram, the O's are up and then you have your H's or your hydrogens that are downward. Oxygens, your O's, which are red, those have a more negative charge. They're the negative side of water. And then your H's, your hydrogens, have more of a positive charge and are thus your positive end of a water molecule. Because they have that unequal distribution, they're called polar molecules. Just like a magnet has two different ends, a positive and a negative, so does water. It has a positive end, the hydrogen, and a negative end, the oxygen. Cohesion is a second property of water. Water can be attracted to each other, meaning that water bonds to water, as you can see by that little diagram of the one water molecule holding another water molecule's hand. Because of this, it creates something we call surface tension. You can kind of think of that like skin on top of water, or an extra layer. Have you ever been down by a creek or to a pond or to a river and you see the little bugs, those little insects that kind of float around? Those things are called water striders. They're actually using that surface tension to their advantage so they can walk or run on top of the water. Also, down by that river or creek, you may have seen things floating in water or even in a pool. That also, if you look at the picture, that's the flower floating in a pool. It's using surface tension to allow it to float so it doesn't sink. Adhesion is a third property of water, and that is when water forms hydrogen bonds with other molecules. And you see the little water molecule down below holding a hand of some kind of different molecule. Because of that, this creates capillary action. This allows water to travel up the stem of plants to bring the proper water and nutrients it needs to different parts of that plant. You can also see that there are water droplets forming on that spider web, or that paper towel has that ability to absorb that red liquid that was spilled on the floor. Mixtures, those are a combination of two or more substances in which each keep or retain its individual characteristics and properties. There are two types. One is called a homogeneous mixture, or AKA, meaning also known as a solution. These stay completely uniform or the same throughout. And there are two parts to a solution. One is the solvent, the other one is the solute. And I say that funny for a reason, because they sound and look very similar. Solvent is the substance doing the dissolvent, and solute is the substance that is being dissolved. If you think of salt water, salt would be the solute because it is dissolved in water, thus making water be the solvent since it is dissolving the salt. The other type of mixture is what we call a heterogeneous mixture. This is when all components remain distinct. And there are also two types. You can have a suspension or you can have a colloid. A suspension is when the particles will settle out over time. If you take that Italian dressing bottle you see there and you shake it, what's going to happen? You got it, layers are going to form. If you take it again and shake it even harder and even longer, what's going to happen? Right, layers are going to form. The particles settle out. However, in a colloid, that's when particles do not settle out naturally. And there are a couple of examples there that you can see. The milk, the smoke, blood, butter, mayo, paint, ink are all other examples of colloids. Acids and bases. If you take water and break it down by the equation you see there, it's going to make H pluses, or what we call hydrogen ions, and OH negatives, which is what we call hydroxides. If you're an acid, that means that you release hydrogen ions when you are dissolved in water. You are from 0 to 6.9 the pH scale, you taste sour, and you're tingly to the touch. You can be very corrosive, and you're on the left side of the pH scale. An example would be lemons, stomach acids, tomatoes. On the other side are your bases. Sometimes they're also known as alkaline. Like if you ever heard of an alkaline battery, that means they're made up of bases instead of acids. These release hydroxides in water. They're from 7.1 to 14 on the pH scale. They taste bitter and are slippery to the touch, and they're on the right side of the pH scale. Examples would be ammonia, shampoo, soap. pH is the measure of hydroxide, let me correct myself. They are the hydrogen ion amount in a solution, the H pluses in a solution. Buffers are a mixture that reacts to bring an acid or base back to a certain range. Meaning if you have an upset stomach, normally people tell you take some Tums, take an antacid. Well, it's because your stomach is too acidic, so you're taking that Tum or that buffer, which is basic, to bring your stomach acids back to the proper level. When you draw your pH scale, please remember that it's from 0 to 14. Not less than 0, not greater than 14. From 0 to 14. They're absolute values. From 0 to 6.9 again are your acids. From 7.1 to 14 are your bases. And then in the middle is 7, which is water. Section 3, essential questions. 1. How does the structure of water make it a good solvent? 2. What are the similarities and differences between solutions and suspensions? 3. What are the differences between acids and bases? 4. Describe 3 main properties of water. Vocabulary: polar molecule, mixture, solution, solvent, solute, acid, base, pH, and buffer. This concludes Chapter 6, Section 3. Please click on Section 4 to continue.